Hi everyone, Charles here for ML New Papers. And today I am not alone. I am with a shining star in the field of machine learning research and especially in the field of reinforcement learning. I'm here with Amy Zhang. Amy Zhang, thank you so much for joining us today.
Of course, happy to be here.
Could you introduce your background and who you are?
I grew up in the US, I grew up in California. I went to undergrad at MIT. So in high school and going into MIT, I knew that I really liked math. I actually had very little coding experience. And so I came in knowing I wanted to major in math and then thinking, I have no idea what I'm going to do with a math degree. And so I started to get into computer science. By the end of my undergrad, I knew that I wanted to get a PhD. I didn't necessarily know in what. By then, I ended up staying an extra year to do my master's at MIT, and my research topic ended up being in network coding, so more on the electrical engineering side and signal processing because I really liked kind of like the math involved in information theory. During my master's, I actually did a short internship at Technicolor Research Lab in Palo Alto, and that was my first introduction into machine learning, actually. So that I was actually working on recommendation systems using like Netflix data. So we were using like matrix factorization and subspace clustering in order to basically do kind of like privacy-aware recommendations for users. And I was like, wow, this stuff actually works. You can actually get an algorithm and a paper out like relatively quickly. So, okay, you get this reward relatively quickly. And so I was like, okay, this is now an area where I feel like I can make progress. I'm getting really excited about it. After my master's, I actually got into a PhD program at UCSD, UC San Diego. And at the time, I still was kind of debating between like information theory and machine learning. And actually at UCSD, I was feeling really confused and isolated, and I ended up dropping out of that PhD program after 9 months.
Really?
Yes.
Wow.
Yeah. So PhD take one was a failure. I moved from San Diego back to the Bay Area, back to San Francisco, where I worked at a startup for a little while. I started working in computer vision. So this was actually in 2014, shortly after the deep learning craze started happening, like in 2012, right? So I was like, okay, I want to get into deep learning. I want to get into computer vision. And from the startup, I ended up switching out after a year to go to Facebook. Now Meta, but at the time still Facebook. And there I started on the core data science team as a data scientist. I was actually working on doing building detection from satellite images for this internet.org project that they used to have to provide internet to third world countries. And so in order to do that, they needed to know the population density from satellites in order to determine what was the right way to provide internet, whether it was satellite or drone or Wi-Fi tower. So that was a very rewarding project, but very applied, right? And so I started to learn kind of like a lot of the, at the time, still pretty new deep learning computer vision-based methods like UNets and ConvNets and so on and so forth. And after that, I started to realize that in computer vision, in order to make progress in terms of research, you needed very strong engineering skills. And I also realized that in applications, actually, the algorithm design, the research side of things is not as useful because you get a lot more gains typically from just incorporating more labeled data and doing data cleaning. So from there, I switched to the Facebook AI research team, FAIR, as a research engineer. And after working on vision there for a bit, I kind of decided, okay, I don't really like computer vision very much because I don't really like just kind of like the very heavy engineering aspect of it, just building data pipelines and like handling like large amounts of data. And so then I decided, okay, actually I think reinforcement learning is really interesting because it's got a very mathematical, very nice framework. The algorithms make a lot of sense from a mathematical perspective, and it's much more rigorous compared to like vision, which is a very kind of human-defined, kind of like a messier topic in that sense. So this was now 2016, 2017, and I had started working in reinforcement learning with some folks in FAIR, New York. And then I met Joelle Pinot, who later ended up becoming my PhD advisor. So she had just joined FAIR and was starting up a office in Montreal. And I met her actually when I was attending a machine learning summer school in Toronto, I believe. And I met her and I was like, welcome to FAIR, you know, I love your work. I would love a chance to do a PhD with you. And to my surprise, she was just like, yeah, like, please apply, you know, I'm happy to take you. And so that was 2017. So I immediately applied. I had like a few months until the deadline, so I had to retake the GRE, you know, get my application together. Ended up getting into McGill, and so I moved to Montreal in November of 2017 to start my PhD. From there, I was just doing my PhD in Montreal. I actually also did a couple of visits at UC Berkeley, visiting both Peter Abil and Sergey Levin's groups. So I was kind of just doing a lot of traveling, just really enjoying being a PhD student again. And then ended up graduating remotely in 2021 because of COVID. Then from 2021 to 2023, I was in the Bay Area doing a postdoc at Berkeley while kind of transitioning back into a full-time research scientist role at FAIR. And I also applied for faculty positions. So basically, starting my second year of PhD, I kind of realized, oh, now that I'm getting a PhD, academia is a route that is now open to me. And after having spent a few years at that point in industry and in kind of like a basic research lab in industry, I could kind of see the pros and cons of the industry side. And I kind of decided that I thought academia was a better fit for me and my interests. So I applied for faculty positions in 2021, ended up getting a few offers and chose UT Austin because of the rich kind of like possibilities for collaboration there, including the fact that Peter Stone and at the time Scott Neekum was there. So I started at UT Austin at the beginning of 2023, and then that kind of basically brings us up to today.
All right, Amy, so to get to know you a little more, I'm going to ask you a series of questions. We have 50 seconds. Is that fine for you?
Sounds good.
Let's get started. Which word best describes your research, theory or application?
Both.
Have you ever made a collaboration that you regretted later?
Yes.
Can anyone make a publication at a top conference?
Yes.
Do you think the US is the best country to work in machine learning?
No.
During conferences, do you rather sit at the front row or at the back row?
Depends.
Would you consider having a joint position with a university and a company?
Yes.
Could you give a grade from A to F to the overall review process of top mainstream conferences like ICML or NeurIPS?
I think I would say it used to be a D and it's been progressing up to C, maybe B.
What is the best YouTube channel to learn about machine learning?
This one.
Thank you
Nice
so much.
question.
So I would like to come back on your research in particular. So you're working on reinforcement learning. Mm-hmm. Could you explain for our viewers who are not familiar with reinforcement learning what that is?
Yeah. I think that reinforcement learning is the most interesting type of machine learning. I'm not biased at all. But reinforcement learning is basically the problem setting where you have a sequential decision-making problem and you don't know what the optimal solution is, right? So that's very different from supervised learning. You can kind of think of it as a semi-supervised learning setting because what we do assume we have access to is a reward signal, right? And so we want to learn how to take actions on a time step by time step to maximize that reward signal. One of the other reasons why I'm really interested in RL is I think that the majority of problems that we care about in the world that we deal with are actually RL problems. I think we're not really seeing RL used to its full potential yet. And I think it's partly because there's still a lot of unsolved research problems in the field.
What are the unsolved research problems in the field of reinforcement learning?
Sample efficiency. The assumptions that we build on are very, very sparse, right? Like part of what makes RL algorithms so simple is that we rely on very, very few assumptions about the world, about the dynamics, about our reward. Whereas when we think about sequential decision-making problems in the real world, we usually have a lot of information about them, right? And so how do we incorporate that information into our algorithms so that we can make them more sample efficient, which means that it's actually efficient enough to apply to real-world settings, I think is like the open research problem. That can get broken down into more specific research problems like how do you do offline RL, right? Like how can we do pre-training on large amounts of existing data so that when we train online in our environment, we can kind of adapt more quickly, right? Then there's a question of how do you do offline to online? Because right now, that distribution shift of moving from your offline data distribution to your online one leads to catastrophic performance failures. And then there's, how can we learn from richer sources of signal? Like how can we kind of like easily move around between like learning from expert demonstrations, learning from preferences, learning from language, learning from other types of metadata or information that we have access to, that's a whole other span of research topics to work on.
What are like the applications which are the most popular when it comes to reinforcement learning?
Recommendation systems. Right now they're kind of treated as a supervised learning problem or as a Bandit problem. Bandit problems are, in some sense, kind of like a smaller scale version of reinforcement learning problems, right? They're ones where, we still have to try to find an optimal action to take, but we only care about a single time step as opposed to many time steps. Bandits have been very successful in industry, in applications, right? So they are used for recommendation systems for ads in healthcare. And the reason that Bandits have been successful where RL has not yet is because it's a simplification of the actual problem, right? So in a lot of cases for recommendation systems for healthcare, we actually do want to take into account multiple time steps, but doing so grows the problem size exponentially. And so we just don't have enough data, we don't have the right algorithms to handle it. But really most Bandit problems are really RL ones. Another setting that I'm really interested in is resource allocation. So any kind of like traveling salesman, routing problem, airplane scheduling problem, like all of these are really sequential decision-making problems. So it's really everything.
Wow, that's really everywhere. By the way, for those of you who haven't watched it yet, if you're wondering what the Bandit problem is, I have made a video before. There's the link here or in the description down below somewhere. So don't hesitate to check it out at the end of this video. Another question that I'd like to ask for the researchers who come here, what is the paper or the papers that you are the most proud of? So
there was definitely a paper that came out of my PhD that I think got very popular, which I wasn't really expecting at the time. That was on deep bisimulation for control, where we looked at how can we use state abstractions to do representation learning from high-dimensional observations. This is very applicable to settings like robotics, autonomous driving, where we're trying to do reinforcement learning from extremely high-dimensional inputs, where we know that most of the information or most of the dimensions in that state are actually not going to be very useful, right? There exists kind of like a lower dimensional input space or lower dimensional MDP that if we can find it is much easier for us to solve. That ended up being a spotlight at ICLR, I think in 2021. That really blew up because it had both theory and very impressive empirical results. And so I really like work that has the combination of those two things, and that paper definitely qualifies. There is a more recent paper called VIP, Value-Implicit Pre-Training, where we look at goal-conditioned RL as a type of pre-training on sequential data, unlabeled sequential data, so specifically video. And so we show that you can look at pre-training on sequential data like video or language as a reinforcement learning problem. This is a direction that I'm really excited about continuing into the future because I think especially with the recent craze around LLMs, the kind of autoregressive pre-training regime, RLHF, or learning from preferences fine-tuning, I think that those ideas are a little bit clunky. And we should be looking at it from a reinforcement learning perspective, which could give rise potentially to simpler, more elegant algorithms that kind of merge those two stages. If you think about it, that kind of this generation of sequential data for video generation and LLMs is a reinforcement learning problem.
I'll put the link of the papers in the description down below. For those of you who are interested, want to check, I will definitely check them. Now there's a topic I would like to speak to you about, which is about conferences, networking, and collaborating. In a researcher's life, conferences and workshops are really important. And I would like to ask you, why should we go to conferences and workshops? Even if we don't have like a paper, for example, why should we go there?
I think especially when you start out in research, the assumption is that research is a very solitary sport. You know, you are just trying to come up with an idea, develop an algorithm, run experiments, get a paper out. And actually, research is very social. To be a successful researcher, right, you have to convince other people that your research is the right direction to go. It's really hard to do that if you don't go to workshops and conferences and understand what other people are excited about, right? Because if you don't know how they think, then how are you going to be able to convince them that your work is important? So just kind of like from a buying and selling of ideas perspective, right? Like it's really important to go to these types of events. I personally also found early on as a PhD student, it was pretty hard for me to find collaborations, and I really enjoyed collaborations. Like I actually did not really enjoy like the solitary aspect of doing research. And so a lot of my early collaborations were found at conferences, just from randomly chatting with people at their posters or randomly meeting people and just like having conversations and getting excited about research directions, and then deciding to, you know, let's start a weekly meeting and discuss and turn that into a project. So for me, like a lot of how I built my network, how I found my collaborators was through attending conferences.
I think that's really interesting. Like I see personally, like when I go to poster sessions at conferences or summer school as well, like I have this tendency that I like the topic, I speak to the presenter, and I don't have this good reflex to keep contact with the person and keep chatting with the person and doing meetings. Well, I think that's, as you said, that's probably the key to make like good collaboration. So I think that's a really nice tip and advice that Amy just gave us now. I've got a question here. Like, so you were talking when you see somebody's topic and you say, okay, I can collaborate with you. How about the other way around? Like you have a topic and some people are interested and want to collaborate with you. I have this idea for me, for example, that it's a little bit scary that what if my topic is not so nice and I take with me a lot of people and at the end maybe just the topic is wrong?
I don't think it works like that. So, you know, even now I have bad days where I get up and I'm like, my research is garbage. I have no idea why I'm doing anything that I'm doing, you know, like what is going on? I think when you feel that way about your research project, the right thing to do is to stop, step back, go outside, get a cup of coffee. You know, I don't think, I just think it's very unlikely that you have found yourself in a situation where you've convinced all of these people that all of these other people are interested in this research project and you've just managed to dupe them somehow and it actually is garbage. Like I don't think it works that way. You can have negative results in a project where you go in a direction and it turns out maybe it's a dead end, but this is also part of like the experiment design and how you do research. Like if you get a negative result, why did you get that negative result? Why did you assume that you would get a positive result to begin with? You know, there's a lot of things that you can still uncover there. And I think a lot of people have shown that you can write very successful, very influential papers about negative results. So that's kind of like a two-part answer of one is you should probably just step back and, you know, try to focus on your mental health, and that's probably why you think everything is garbage. And two is that, you know, there are a lot of different ways to do research, and just because you have negative results or don't think a direction is promising doesn't mean that everything, you know, that everything you've done is wasted.
Final question before the end of this interview. Many enthusiasts watching this YouTube channel have some background in some field, whether it's computer science, economics, mathematics, statistics, whatever it is, and maybe amazed by some application that we see out there and the applications of reinforcement learning or reinforcement learning related topics. I would like to know what advice you would give to those people who may want to pursue a career in tech or in machine learning as researcher, engineers, data scientists, or something else.
So I think now is a really good time to get into reinforcement learning. There are so many resources available that there didn't used to be. A lot of tutorials, a lot of videos, a lot of lectures to get up to speed on RL algorithms and deep RL and implementing RL algorithms. There are a lot of code bases available. RL is much more reproducible than it used to be in the past, thanks a lot to the efforts of my advisor, Joël Pinot. So, you know, there's a lot of resources available. There's a lot of benchmarks, a lot of, you know, possible applications applications that you can just dive straight into. The data is out there, the algorithms are out there, in code bases, the evaluation metrics are out there. So, I think you should just go out and run your experiments and try things out. Just get a sense of what performance looks like, how to debug, and write up a blog post on your findings.
Amy Zhang, thank you so much for joining us today. And thank you for watching this video. Thank you so much, you really help this channel a lot. If you enjoy this new type of format of interviews, just let me know in the comment section down below. If you enjoyed this video, don't forget to give it a thumbs up, subscribe, hit the bell icon to get notified of the next video. I upload new content every week or every 2 weeks. So stay tuned. Thank you again so much for watching. I wish you a wonderful week and I see you in the next video. Cheers.